Welcome to Cloud Native Live. Thanks for joining us today. Here we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee. I'm a developer advocate at VMware Tanzu by Broadcom. Every week we bring new presenters to showcase how to work with cloud native technologies. So we'll build things, we'll break things, and we'll answer your questions. So today we have Rafiq Haravi with us to talk about how to use cloud native application threat modeling and adversary emulation. So I'm super psyched for that. But I got to go through this code of conduct thing. This is an official live stream of the CNCF, and as such, it's subject to the CNCF code of conduct. So that basically means be nice to each other. Don't add anything to the chat that would be in violation of the code of conduct. Be nice to your fellow chatmates. Be nice to me. Be nice to Rafiq, and we'll return the favor. It's going to be great. Friends who are joining us live, please do say hi in the chat and tell us where you're tuning in from. I love that this is a global stream. And if you have any questions during the presentation, go ahead and post them to chat. We're going to try to make this more conversational, and we'll interrupt and dig into your questions as we move through the presentation today. So with that, I'm going to hand it over to Rafiq to kick off today's presentation. Hello, Rafiq.
Hello, Whitney. Thank you very much for the presentation. My name is Rafiq Haravi. I've been in the IT world for almost 15 years right now. And I've been spending my last 3 years and a half with Sysdig, working mainly with customers in Europe and Middle East, helping them to securely move to cloud, mainly containers, Kubernetes, and cloud services. Before that, I've been working in consulting mainly with big consulting company like Deloitte and Entity Data, moving on-prem workloads to cloud. And for those who don't know, Sysdig is a cloud-native security and observability company. We are offering a cloud-native application protection platform. And also, we are the company behind Falco, which is the CNCF project for threat detection and response for containers, Kubernetes, and cloud. You can get here my LinkedIn profile, my Twitter profile as well. Please feel free to reach to me and contact me. With that said, let me move to the agenda of today. So we have a packet agenda for today. We'll be start talking around the cloud native application building blocks, all the different components that are part of a cloud native application. Then we go through the multitude of cloud attack surface and the different challenges that come with. We follow that by threat modeling techniques for the purpose of cloud native application, then going with the adversary emulation. And finally, we'll be finishing by tooling. I will be only mentioning open source tooling, nothing property, no worries on that, and some takeaways as well. So with that said, I'll be just making a small introduction here. Once upon a time, maybe not like so far, we've been deploying and delivering application like for virtual machines or maybe physical machines. And it was a little bit much or less easier to protect them. You can't put a kind of firewall or endpoint detection and response system in the front, kind of someone here on the bridge, and you'll be spotting those intrusions coming to your system or your environment. So it was a kind of straightforward protection system, but this is no longer the case when it comes to cloud, for the simple reason that cloud providers are public, they own external connection, they are exposed to outside world, and they are bid with different services that you can't consume on the shelf. So you need to control access to services, give access both to those services and to the users or the team that are using the services. And you need to give the right access to the right team, to the right service at the right moment. So this is generate as well a lot of logs. So detecting unusual activity become more and more hard. So let's see how this is in a cloud native application. So usually you have your workload that is favorably working as containers. Maybe if you are more advanced in your cloud native journey, you would go for services, or just like moving workloads from on-prem to cloud as is, like just bringing one VM, put it as an instance on top of Google, AWS, Azure. So this is the workload. And on the most of the cases, this is running on top of Kubernetes, whatever is managed by a cloud provider, or you are building by yourself on-prem or on top of cloud provider, plus container as a service. So we have this, let's say, the business intelligence or the business value of your application. And here around, we have a set of like other capabilities or other services that I'm always referred to as satellite services, something like identity and management, network and security, load balancing, for example, management service like logging and monitoring. This is something that you need with distributed system for sure. Otherwise, you are lost. And finally, you get those data. Like the data is valuable for you, so you use different type of data store like database, object stores, block stores, and so on. So this is like a typical cloud native application which is running on cloud infrastructure or maybe on-prem Kubernetes. So we see here that we have like 4 layers of security. We refer to this for 4C. The first one, be starting building a code. This is your code that you put it in a container. You have a first layer of abstraction there. And then you will deploy to Kubernetes. So you'll be deploying this in a pod. This is the second layer of abstraction in a namespace. You make sure that there is an abstraction or like a containerized space, sorry. And finally, you have the cloud provider. On the cloud provider, you have multi-account, you have folders, organization, and so on. So you have this 4 layer of abstraction. The challenge that come with this, that those cloud native applications are really dynamic. What I mean by that, today you have your developer, DevOps team, they have a list of services offered by those cloud providers, and they can use it on the fly. It's no longer like the old enterprise architecture world when someone defined the architecture and revisited it 6 months, 1 year to make sure it's aligned. Today, the application team or the service team can move from one service to another, change the architecture to align with the business requirement, and to be challenged on time to market. So you need to be agile. That means that you need to pick the right service, and this is make the application dynamic, but by consequence, making also the surface attack dynamic. The second thing, which is quite interesting, that those threat actors, those bad actors, they are using the same tool. So if you are using Terraform, for example, or CloudFormation to automate your deployment, accelerate your deployment, they are using the same tool. If you are using, for example, GPT, ChatGPT, or other like GPT solution to search for solution, they are using them for searching for malwares and so on. So they are using the same tools, and they are going with the same speed as you, if not much speeder than you. The second thing, when it comes to having one monolithic system that will be distributed, this is generate a lot of interaction. And by the way, this is allowed by default the attack service. We have also all these logs that are generated. So like comparing to one-to-one system or three-layer system that we know from the legacy world, this is a big graph. Also, you have lack of visibility because of the system running on different boundaries. And finally, this big issue, let's say, on the culture or agility, when you have the cloud delivery team that is trying to optimize time to market versus the security team that maybe they are using the same old process methodology and tools. So in a nutshell, this is the main challenges. Before digging into the threat modeling, I would like to mention something here really important. I was reading an article from John Lambert, which is from Microsoft Security research team. And here I'm quoting what he's saying. He's saying defender think in lists, attackers think in graphs. As long as this is true, attackers wins. And this is mean that as a security team or as DevOps team or even as a dev team today, you are just struggling to make your application or the infrastructure either non-vulnerable or compliant with some regulation. If you are in financial services, with PCI, with others, and you are just having some checklist to check and make sure that I'm not looking at the whole picture, but I'm just trying to have my checklist done and go to production. But the attackers, they are trying to connect the dot from one piece to another and try to find the path from initial access to your system and to gaining a full access and extraction Sunday. So please keep this in mind, that this is something that when you start doing thread modeling and adversary emulation, it's really, really interesting to understand how those guys think. So a couple of definition for those guys that are not coming from security background. We know that there is like this big movement of DevSecOps. So a lot of people coming from dev to security and other coming from security to dev. So let's make sure that we are all in line. Thread modeling is the exercise to be identifying the different building blocks of your system, the communication between them, in order to spot any threat and protect something valuable. And this is really interesting. I will give you an example. Today, if you have like an S3 bucket that is hosting your like images or files that you are using in your public website, it doesn't make sense if it's public or private. But because those documents or those images are public, there is no value from there. So it doesn't make sense. We need always to think if this is something valuable, confidential, IP or like personal information or stuff like that for the company, and then start to protect them. So the goal of threat modeling is to identify the threats, the actors, and then start thinking about providing mitigation. On the other side, the adversary emulation will be simulating the tactics, techniques, and processes that is coming from real world threat actors to test an organization resiliency. So you are putting your feet in the shoes of an attacker, and then you start thinking the same way, using the same tactics, techniques, and you test your resiliency. And the idea here is that you can, by the end, assess your resiliency plus provide mitigation.
I like this a lot. For one thing, I think one of the things I've taken away from your presentation so far is just like the sheer complexity of systems, and then how difficult it must be to secure. And I'm very interested to hear your solutions, which must be coming up. But then this is the first I've heard of the term adversary emulation, and to me, it reminds me of chaos engineering, where you break your system on purpose so you can expose the flaws before an actual event happens. So that's the question in the end. Is it the same? Do you think those things are similar?
Yeah, I would say it should be chaos engineering for security. I mean, because chaos engineering is concerning everything like scalability of the system, high availability, resiliency, and stuff like this. Let's say that adversary emulation is the chaos engineering for security. Be prepared to be attacked, to be leaked, and see how you provide the different procedures and the different mitigation to avoid that attack or limit it. So yeah,
awesome. I love it.
There is a lot of similarity between the two words, because in the two words you are trying to break the system from security point of view for adversary emulation, and from like resiliency, scalability, and so on, availability for the case engineering.
I love it. Thank you.
Nice. Thank you. So within that, let's go to the threat modeling techniques. There is a lot of methodology or techniques for threat modeling. The most famous one is Stride, which is created by Microsoft and defining 6 categories we'll look after later. The second one is the attack tree. And the attack tree consists in defining a multi-level diagram, which is with one root, different leaves, and children. And wherever all these children are satisfied, the root is satisfied. And that means that an attack can be possible. The third one is data flow, which is defining a graphical presentation of your system, the different component interaction of them, and then help you make something contextualized and try to finding some threads. So the pillar for that are system architecture. You need to define your system architecture, make sure that is reflecting the real world of your like current system. Defining actors, other like good actors and bad actors, because even good actors, if they are compromised, they become bad actors. defining the list of thread or finding the list of thread, and providing mitigation. So this is like the 4 pillars of threat modeling.
I have a question about
Yes.
methodologies. Are those meant to, is it common for a company to choose one methodology and that's their methodology, or are you meant to do all of these things as a way to threat model?
I would say it's a mix of the three. There is other methodology, of course, but it's a mix of the three. You cannot just use one because depending on your system, for example, attack tree is very famous, for example, to define like interaction between the system and spot like the highly risky assets. Data flow, let's say, help you to define like different entry points. So it should be always a mix of three. I rarely see a company that is just using one methodology, and there is others. I'm just mentioning those top three, I would say.
Thank you.
So the thread approach. So thread is like categorizing those threads in 6 categories: the spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And let's say that we have this example of digital bank example. So what we're doing here, we define the different building blocks. Then we define the different interaction between them. And when we define the different interaction, we define also the trusted boundary. And the trusted boundary is the kind of those services that they can't talk together. So we can say that, for example, here the payment gateway can talk to the notification service to say someone that we just process your payment. So this is kind of the like the high level of thread approach, and then you start sporting the thread and put it in the category. So the idea here that you have to decompose the system into different component models, defining the relationship between them. This is the first step. And then I would like to spot here the different persona for thread modeling. This is really interesting to engage all the people. The business owner will be always invoked in balancing, doing some balance or like some studies around the business requirement on one hand and mitigation to address those threats. So we need to go fast, for example, time to market, but we need to make sure that we are not harming our business. So the business owner is owning like the risk and validating that we can do it, of course, with the validation of security. The app or the service developer will be facilitating brainstorming the application architecture, and finally he will implement or they will implement the mitigation. On the adversary side, we have this adversary that can be someone from the company, someone hired as consulting and stuff like this, and he will be simulating an authorized user, try to break the system and find potential threats. The defender will be defining security control to mitigate the threats, and will be working closely with security architect who will provide the guidance, which is like industry best practices like CS benchmarks, or let's say compliance framework if you are a regulated company. So for that, let's start with the thread modeling for the cloud native. I will do this example for containers, Kubernetes, and the cloud, because this is like the most big, let's say, component that define today like a cloud native environment. So for container, I'm just spotting here the WASP Docker thread. And you can see from this diagram, you have different threads, some of them coming from like legacy world, like DOS attack, like compromised secret and stuff like this. And some come with a specific architecture of container, like container outbreak and so on. So just keep in mind that this is like a big picture of the different threads. So we'll use here the data flow diagram for containers to see the life cycle of containers, and then lately spot the different breakpoint or the thread that can come. First of all, we have the developer who is developing business code using any programming language, but he will also deliver container manifest, Kubernetes manifest, and so on. We are focusing on container now, pushing this to your source repository, and then you have your CI pipeline with building and pushing the container image to a container registry. From there, the image will be available to be deployed. So we'll be pulling around the container image. This is we go to the container host, which is having the kernel plus the container engine. The container, we talk to the kernel to execute some action. The container socket can talk to container engine as well. We have the container engine, which is talking to the kernel. And we have this container which is talking to container. This is something that can be normal if you have a microservice A which is talking to microservice B, or can be a malicious configuration if we don't have the right isolation. So it can be malicious or not. So if you would like to go here and spot the threat vector, I will I'm just mentioning the most common, but the picture is quite big than what I'm spotting here, just for your knowledge. So the first thing that you have a vulnerable operating system or container engine that is vulnerable with a non-vulnerability that can be exploitable. Second thing, which is coming from the legacy world, it's the vulnerability container or application that is vulnerable. So you have this application, for example, that is exposing log4j, and you can do a remote code execution, for example. Exposed container engine without, for example, TLS, without any protection, authentication, and so on. This is a thread that someone can hook on the container engine and then bootstrap a new container, a malicious container, change the configurations. We have the unsecure image registry, which someone can hook into, temper an image, create a new tag, for example, or just push a new vulnerable image that he can pull later in your host on your cluster. Privileged container that they have access to the kernel and they can we can use it to do lateral movement for malicious activity, and misconfigured container as well. And finally, as I mentioned, this escalation on the host. So this is the most common one, but there is the list is wider than what I'm mentioning here. And finally, I missed this last one, which is an insufficient network oscillation between container. When a container A, for example, which is a front-end container, can access to the database container and maybe get the password. The second step will be, after you define all these threads, possible thread, you just start categorizing those threads in the thread methodology. For example, for the spoofing, someone who is spoofing, like modifying the source code and modifying the container manifest. For the tampering, someone who's tampering the application code directly in the source code or using the CI/CD, and so on. So I'm making here some example just to let you know that when you spot all the threads that is make sense in your environment with the technology, with the architecture that you are using, then you start categorizing. The third step will be mitigation, and we talk later about mitigation in the cloud path. So let's move now, after seeing how we do thread modeling for container and introduction, let's move for the Kubernetes thread modeling. And I'm spotting here the different boundaries that come with Kubernetes. So we have a container that is included or part of the pod. This is the first layer of protection. Then we have the namespace. We have the node. This is like physical separation. And finally, we have the cluster. This is the default security boundaries, but we see that this is not enough for Kubernetes. So here I would like to spot the Kubernetes attack surface. I'm using this example that have been done by the CNCF financial user group 2 or 3 years ago, which is a good example showing how we do the threat modeling for Kubernetes. Here you can see that we have the different building blocks. Here, all the components that are part of my control plane, all the components, they are part of my worker node, and finally, the components that are part of the image registry. And you can see here, we define data flow from one component to another, the trusted boundary that we told earlier, the machine segregation. This is like presenting a process or component, and this is presenting a data store. So let's start with defining the different machine segregation. So you can see here, maybe most of you are familiar with that. We have the control plane, we have the worker node, and we have the image registry. And here I start doing the trust boundary. The API server can talk to the TCP. The controller has its own trust boundary, and the scheduler as well. On the other, yes.
Is the trust boundary the same as a threat boundary?
Good question. Let me think a little bit about it. When you define trust boundary, I mean that you are supposed those components are supposed to talk to each other. So it's not the same. It's not the same. The trust boundary that you assume that the API server is fine to talk to the CCD. So it's but if something go from outside here, this is breaking the trust boundary. So if you would like, for example, the API server talking to the scheduler or the controller, you need to define this. But you are not
Okay.
controlling what is happening into the stress boundary, because you're still gathering like logs and evidence and stuff like this. But at least from architecture point of view, API server talking the etcd, that's normal. And for example, image repository getting an image, that's normal. So yeah, but if something break
Okay.
into, that will be
Mm-hmm.
a threat.
Got it. Thank you.
Thank you. So I do the same for the worker node. Everything around kubelet and situating the container D, image cache, and RAC will be a trust boundary. The kubelet will be talking to all these components. Similar for kube proxy, who is responsible for modifying the AP table. This is another trust boundary. And finally, we have the pod. And we finish with the image registry when the image repository will get the image data. The next step will be to define the data flow here. So let's assume that we have we would like to deploy something. We would like to deploy sample application. So a user here, we just hit apply deploy. It will come to the API server, and here we will check if this is a new application deployed or is it imitation of an existing deployment. So we do a couple of check with the controller to define the desired state and so on, like the number of replica and so on. And finally, if the application never been deployed, we'll schedule the application using the scheduler. And when this is done, what it will happen, the kubelet will pull the new pod. It will try to see to hit the Docker run, or yeah, and then they will try to see. It will try to see if the image is available in the cache. If the image is available in the cache, no need to bring it from the image repository. In the other case, what will be do? We get the image will be loaded and send it back to the container D, which will be sending to RANC for instantiation. So we finish this instantiation, and the second part will be defining the kube proxy will be pulling the service, the endpoint, and configure the AP table to expose the application. So if you can see here that this is quite complex, there is a lot of interaction, and each interaction and each endpoint can be a potential threat. So you need to assess all of them. For the purpose of the presentation, I just make it like more simple, more condensated here. I'm just spotting the most common one. So you can see here, the first thing that we are seeing is that access to Kubernetes API server or an etcd server, most of this happen because people forgot to secure their endpoint. And this is like very, very common today. If you use any like discovery service, you find on the internet that there is a lot of Kubernetes API server and etcd API and etcd server that are exposed through the API. The second thing, if you are deploying Kubernetes with a dashboard, maybe in this configuration, in dashboard can be used by a malicious user to go into the platform and do deployment, and it's much simpler than hooking into a system or a host. Next one, which is malicious container image in the registry that be deployed to the cluster and then expose the cluster. The well-known application that with an exploitable vulnerability. Also, if you are not well defining your secret, or you're just mounting your secret in your pod, someone who accesses the pod can get the secret and then do extra lateral movement. And finally, a Docker daemon that is misconfigured allow the attacker to gain access to the host and do lateral movement. So this is like the top common Kubernetes misconfiguration that the threat actors will use. And you can see that we start spotting the different weakness point, and we need to provide mitigation. So let's move to the cloud threat modeling. Here I'll be just showing an example using Google Cloud Storage. You can see here that we have different layers that come by default. The cloud platform, you will have your account and you have your organization, different folder and stuff like this. This is like a first layer of abstraction, and inside the project, you will have the Google Cloud Storage instance. This is an example. I take it from the NCS group. They have been doing research around this, and this is quite explainable. That's why I put it here. So here I'm putting the cloud storage, and then I'm defining the different boundaries. You can see that we are defining the different boundaries, the different services that are working with cloud storage. And also we are defining the different actors here. We can have admin, storage user, any GCP, any other GCP project access to this specific storage, external user, and other GCP services as well. So what I'll be doing here, I'll be defining one interaction here. Someone, an admin user who wanted to access a bucket. So how it's working, he will be accessing either through the Cloud Console or the Cloud API. Then he will get to the organization policy, doing some the organization policy. We define whatever or not he has access. We got this policy to the cloud storage. And if he has access, we get to the bucket, step number 4 here. And if you are enabling logging and monitoring, you will write something to your logging service and monitoring service. So this is just one flow. And if we would like to do it for each user and each interaction, this will be more and more complex, and it will end up by something like this. So just to give you the example, the link here, I will share the presentation later, so you can go into details. So the idea here that we start like spotting which is valuable. That's really interesting and really important. Just focus what is valuable for the company. So for me, it will be, in this case, all the authentication token that can be compromised or leaked, plus the data that are inside the bucket, and also the log data that can be valuable because we are exposing some sensitive information, IP addresses, other that can be used for further action. So we have we spotted 3 valuable data that we should protect. And then the next step, I'll be starting defining the different threat actors. It could be an internal attacker or an internal malicious user. They are trying to do something that is not allowed or permitted. Also, a compromised internal user, someone who got leaked on his laptop, someone access to his laptop and get those information. Compromised external user, a partner or someone who is working in your environment. Also, an internal attacker who find a way to access to your environment over internet. Cloud provider infrastructure engineer, this is like not likely to happen, but it is still a threat. And when I'm defining all these threads, I will work on one of the scenarios. So let's say that I would like to see if someone with thefting credential or access token, how he can access my environment. So here we can see that we are defining this attacker who will be thefting the credential. We're defining the different type of attackers, like an internal one, internal malicious user, or external attacker, and they are all doing the same action. And we can define the workflow until we get to the cloud storage, either through the console or the API, to finally to get to the bucket storage. So the asset we protect here is the bucket, and the impact, if the user has just read and write permission, they will just get the data, but if they have admin permission, they can even modify the bucket and export other stuff. So this is really important. And then we start categorizing this. We put this as a categorize of spoofing, escalation of privilege. And finally, I'll be giving an example here. For example, I define all my thread. There is a person that start thinking about enabling different actions or providing different methodology to provide to protect, like enabling MFA, putting strong password, restricting the PC access, putting like the token that expire in a while and they are refreshed often and stuff like this. So this is like the third step of thread modeling, which is after detecting the thread, providing a mitigation. So within that, let's move to the cloud native adversary. And the cloud native adversary, as I mentioned earlier, it's to put yourself in the shoes of the adversary. There is a well-known organization called Metri that's been providing a common language and understanding of adversary behavior. And they are getting all this behavior and all these tactics, techniques, and procedure from real-world cyber attack. So the idea is they provide this to the companies, government, public organization, private sector, that provide you help to define your adversary emulation strategy. So the most known framework is Mitri attack, and we stick within this framework during the presentation. So how it's defining? We define a set of tactics. You can see that is starting from just having an initial access, doing some execution, escalation, and so on, defense evasion, until getting the latest step, which is exfiltration and impact on the organization. So this is the first line. And then for each tactic, we have different techniques. So here we define different techniques, and for each techniques, we could have one or more sub-techniques, which is the case here for valid accounts. And for each sub-techniques, we'll have the procedure, how we execute it, the mitigation, a way to mitigate this, like for your team, and finally, a detection. I would like to be able to detect this. How can I enable my logs, put some rules, and so on, to be able to detect such kind of procedure. We have the Mitri attack provide one matrix that is available for container. This is all the techniques, tactics, techniques, and procedure that are for container. You can see that we just have those techniques that are, let's say, make sense in the world of container. Microsoft has developed one for Kubernetes that is quite similar. We are focusing on Kubernetes. And finally, we have a matrix which is dedicated to cloud, that is covering today the top cloud provider, AWS, Google, GCP, and Azure, plus the some SaaS services. So just keep in mind, whatever you start working on adversary emulation, you have these three matrix that you can start looking into. So how is working the workflow for cloud attack emulation? First of all, you have to choose the Mitri attack technique that you will be using. Then you choose a test run for this technique. You execute the test for the procedure. Then you analyze what you find, the detection. And finally, you do implementation, and it's an iterative process. So you have to do it for different scenarios. You have to replay whatever the infrastructure change, whatever new services coming or stuff like this. So make sure that this is an iterative process, the same way today that you are doing an iterative DevOps like workflow. You have to do the security the same way. So the last part of the presentation will be focusing on the tools. I will start with the Atomic Red tool, which is an open source framework that is providing a libraries of tests for the different MITRE attacks, the procedures that we saw earlier. So, and this is covered mainly the top 3 cloud provider plus Kubernetes plus container. So it's a very good start. And I'm just putting here an example. They will provide you, for example, an example like this when you are trying to create the key, you are trying to get the credential, and finally you are trying to extract the key from the credential. So this is give you an example if something could happen like this could happen in your infrastructure or not. And we see later how there is some tool that will be help you to automate these attacks. So on the Kubernetes, for those who are beginner for Kubernetes, I find this matrix which is provided by a Switzerland company called Redguard. What I like from here that they are just giving a very simple example for each attack. For example, here for backdoor container, you can see that we're providing a very simple attack with an example, so you can play it around your infrastructure and start learning. This is really, really very simple, but really interesting. Caldera is an automated adversary emulation tool, so you can use the built-in behavior mapped to attack metrics. You can use the techniques that are like provided in Atomic Red team, and then you automate this. Whatever you want to run it on weekly basis, on monthly basis, you make sure that this is running and you get the result and you can improve your posture. Attack Workbench is a kind of knowledge base that you can use it internally to customize the MITRE attack to your organization, create some additional information, annotation, and share knowledge internally. MITRE Detect is not an official MITRE project, but it's helped you to spot the different gap in your infrastructure. Let's say, I will give you an example if you would like to be able to detect if someone is creating cluster log or Kubernetes For example, you need to activate the Kubernetes audit log. So the MITRE detector will spot you this path and telling you, hey, in order to be protected on this level, please activate those logs, for example, and build threat detection on top of that. There is one tool from AWS that I like because it's a high-level tool. When you give in entry the application metadata, you describe just your application, you give assumption. Yes, any question?
We have a question that I think is a wonderful question because so you did a great job of convincing me, at least, probably everyone watching, that it's a very complex world out there and there's a lot of attack surfaces and it's kind of overwhelming.
That's true.
Maybe by design. And now you're providing, okay, here are tools and frameworks that work in all these different contexts, which is like a relief for me because I'm just like, okay, good. Like, I'm glad people have figured this out and I can follow the matrices. But I think now people are wanting to know how to capture all this information to be able to go to these resources later, especially the ones that are applicable to them. So as the host, I don't know where let me say I'm just the host. I didn't organize this session, so I don't know where it will live within the CNCF space. I'll do my best to make sure in the YouTube video replay that we put a link to your presentation there. But Rafiq, how do you feel about putting a link to your presentation in your Twitter or somewhere publicly that people can reach
otherwise, because I've been running this on the KubeCon last week. Let me just speaker deck Rafiq 8.
So especially a place where we can get to these links where they're a clickable link and not these long links that we can't.
Okay, I see what you mean. Okay, we'll share the presentation, like the slides, so they can play with the animation.
Okay,
makes sense.
Will you share the slides to your Twitter handle?
Yeah, I will do it.
Okay,
Let me write this down here.
When someone's saying maybe share them here in the chat, but I think, do you have a link to your? It's not quite that easy, I think.
Yeah, I will make a copy, read only copy, and then later when we finish, I make a read only copy, and then I will share it on the chat. Yeah.
Okay, great, cool.
Awesome. So here, this AWS Threat Composer, it's a high-level tool that will give you put your application metadata, you make some assumption, and then you will get the threads and the mitigation. And this is like an iterative way. You get thread model document. You can even put an architecture diagram, and by the end, you will get something like this. So it will spot you the different thread that you are exposed to. You get the category or the priority of each thread, and finally, you can see here on the right of the screen that you have the different thread mapped to the stride framework sets, different six category of stride framework. So this is something that maybe you can start playing around. I can hit the link here, show you the example that is provided by default. Here you go to this thread model. I think that we have one example. Here we go, Thread Composer, and here you can see the example, and you can see that you are putting the application info, the summary of your application, the architecture. You can even put your architecture diagram, defining the data flow if you wanna, making the assumption. And by the end, you can see that we are making a lot of assumption here that TLS 1.2 is adequate, etc. And by the end, you get this. Yeah, go ahead.
Do you mean to be sharing your browser screen right now?
Oh, sorry, because I was okay.
It's okay.
No, I thought I shared the wall. I'm just sharing the slides, so no worries. You will find the link later. Okay, and then we have you got the threads here. You can see that you got the list of threads, and then you can navigate it and start like prioritizing different threads. Another tool which is threat-to-threat SIEM, and it comes a set of libraries similar that map to MITRE ATT&CK, and they cover AWS, GCP, Azure, and Kubernetes as of today. And you have different techniques that you detonate, you play it like this, and then you get the results. So this is like very straightforward tool that can give you a list of attacks, and then you can see here that we've been able to execute two attacks. Finally, I would like to get you a couple of offensive toolkit that you can learn and reuse it, like for the Linux purpose pack, which is an AWS exploitation framework that is designed for offensive security. Cloud Goat, which is an application that is vulnerable by design, so you can deploy the Kubernetes cluster, deploy any security tool, and you can start spotting the misconfiguration and learn from. For Azure, we have Microburst and Pauser, which is quite good tools. And for Google Cloud, I'm putting here the Google Cloud Platform Security Control Mapping. With that said, we come to the takeaway. First of all, I would like to mention that this is really important to treat security the same way you treat your DevOps workflow. So could be automated. It should be automated. Sorry, it should be managed as a code, and should be you have this policy-driven security in place. Use the cloud native tools, observability and tracing tools are really they will get you insight in your environment, just to understand how these blocks are communicating and spotting this configuration. So let's say if you are using an observability tool or a tracing tool, the nice UI that can spot the different objects of your Kubernetes cluster and just start mapping the communication between them, it will be really helpful to spot if you are aligned with the architecture or not. Last thing, the next one is try to translate this policy into consistent, effective, and actionable task. Whatever something happen, the security engineer or the SOC, they will have a list of action to check, and then a list of action to execute, or to iterate the workload. And finally, the most important thing in Graph, not at least, make sure that the attacker is just trying to connect the dot and find a way to enter your environment where some other just trying to make sure that they are compliant. I'll put the list of some further reading. They are quite interesting here. If you can share it with me with the audience, and I will make sure to share the slide later on my Twitter.
I'm putting the links in the chat now, but I think based on my side of the interface, it might only be going to the YouTube stream and not the
okay. Anyway, I'll be sharing tonight. I'll be sharing tonight the slides. Everyone who has my Twitter account, let me go back just to spot my Twitter account.
Oh, it's on your handle. We can see it in
okay. Nice.
Rafiq 8. Like it's on the
underscore.
The underscore Rafiq 8 underscore.
Nice.
Yes.
Or just type Rafiq Arabi on Twitter, you will find me.
Yes. Excellent. This has been so valuable. Thank you so much for your time today.
Thank you very much. Thank you very much for your presence. Any question, I'm happy to answer.
I've been asking the questions as we go, so we don't have any right now, but we can give it a minute. So to be clear, what's going to happen? You're going to give me a link to your presentation, and I'll see about getting it into the description
exactly
on the YouTube video. And then meanwhile, you're also going to post that link to your own personal Twitter, so people can find it there too.
Yes.
Okay. Cool. All right. I think no questions have come in, so I'm going to go ahead and say the ending script. We got some thank yous, which I'll thank you
Thank you
for sharing. Thanks everyone who shared their valuable time and attention with us, and thanks Rafiq for teaching us about cloud native application threat modeling, which is vast, but they're wonderful tools. I really loved the idea of adversary emulation, and to me, and you agreed, it's like chaos engineering, but for security, where you try to think like an attacker, and all the great frameworks and tools that are out there to do that. So thank you. So here at Cloud Native Live, we bring you the latest in Cloud Native. We dive into the code every Wednesday at noon US Eastern, so at the same time. Thanks again for joining us today, and we'll see you again soon. Thank you. Goodbye.
Cheers.
Thank you, Rafiq.
Bye-bye.